Howdy, my name is Synclaire Truesdale, and my project is the rapid deployment of Argo floats along hurricane tracks. The main scientific topic that drove this project was the biological response that occurs in the upper ocean as a result of a hurricane. And to give you some more background into that, I have a diagram here that's showing that when you have a hurricane that's over the open ocean, it's causing a lot of divergence at the surface because of those strong winds dragging along the water. And this induces vertical mixing in the water column where you're getting upwelling of cold water from below and downwelling of the warmer surface water. And so this provides the environment for a biological response because in addition to that cold water being upwelled, you're also getting an upwelling of nutrients like nitrate and phosphate. And in addition, any existing microorganisms called phytoplankton that are in the water are being pushed more to the surface. So when you have all these ingredients together, being the nutrients, the phytoplankton, and them all being closer to the surface, having more access to sunlight, this allows photosynthesis to occur, which lets the phytoplankton grow and multiply, forming a phytoplankton bloom. Phytoplankton are really important in the Earth's carbon cycle because they draw carbon dioxide from the atmosphere into the ocean. And although a lot of it is respired back to the atmosphere as CO2, there's this net ocean uptake of CO2 down to the deeper ocean where the carbon dioxide can be sequestered or kept from re-entering the atmosphere for many years. And so knowing this relationship between this hurricane and the biological response, it can let us to start thinking about some questions to answer. The first one would be, how will phytoplankton blooms change as hurricanes change in a warming climate? And this is a long-term question because the current prediction for hurricanes is that there will be less number, but they will be more intense. So we want to know how the phytoplankton bloom that occurs after will change due to these hurricanes changing characteristics. But really the main question for this project is a short-term question, which is, what are the relationships between specific hurricane characteristics and a phytoplankton bloom's size and its duration? And so the problem today in the field with answering these short-term questions is the method. The biological response to hurricane has been studied in various other research studies. However, all of these studies have used satellite measurements of chlorophyll A concentration. Chlorophyll A is a proxy for phytoplankton biomass because of the chlorophyll that's located in these organism cells. But as we see with this method, you get a lot of data gaps. We see that here in this time series, and we also see that in the white spaces circled here where we're not seeing any kind of concentration. And this is caused by cloud coverage. And so this is the main downfall of this method. However, my solution that I'm proposing to tackle this is a new method called the rapid deployment method. And so this method will entail deploying biogeochemical Argo floats out the back of planes like those that are used by the NOAA hurricane hunters. And so these planes will be flying into the storms and they'll be dropping, just like they do with drop-ons today, they'll be dropping these Argo floats out the back of the planes where they will be parachuting down to the surface, make it to the water, be released from the parachute, and then be able to start taking profile measurements. And the timings of these float drops will occur at 3 different times. The first one will be before the storm passes, and this would be using the forecasted hurricane storm track. Because of the advancements in the field of meteorology with increasing the accuracy of these storm tracks, I have great confidence we can get a float in the water to get the pre-storm, during storm, and post-storm conditions. The next float drop would occur during the storm, and this would ensure we have an instrument in that hurricane track itself, and as shown here as the plane is flying into the storm. And the last option for a float drop would be optional, but this would be if we did happen to miss where that bloom formation site was. And so if we missed it, we could have a third deployment where we can drop a float into the phytoplankton bloom and measure how it changes through time from that point onward. And these float drops will be occurring off the west coast of the United States. As we see here in this hurricane historical track record, this is where we get a lot of storms in our hurricane season, in fact most of them, and so we'll be getting a lot of opportunities to measure different storms and get different kinds of data for the phytoplankton blooms that occur due to these hurricanes. And so the data collected with these Argo floats will be all kinds of different biogeochemical variables. This includes things like nitrate, oxygen, chlorophyll A, as well as things like the suspended particles, as well as temperature and salinity like a normal Argo float collects. And so we'll be getting a lot of useful data that can help us to quantify things within the phytoplankton bloom and watch how it changes in time. And so the benefits of this method would be that we'll be getting less data gaps than the satellite method. And we'll also be getting a full 4 years of data from each float. And so potentially, looking at these tracks, we could have a float that is useful for more than one storm. And so the last benefit would be that we're expanding the Argo network, but we're giving more floats that have these biogeochemical capabilities. And so we can start moving forward with answering the short-term question and then making predictions for the future. Thank you.